Hi, we're visualizing electric fields today, talking about forces that act at a distance. So remember, we talked about gravity already, and electrical fields are kind of another way to look at fields and how things that aren't touching can have impacts on one another. And fields are kind of our way of explaining that. And I talked a lot about Einstein's idea and the fabric of space time and all of that last time with gravity. Electric fields also pull or push on things, right? That when they're not touching, other charges specifically are affected by electrical fields, but they don't have that like Einsteinian gravitational thing going on, right? It's still a field of influence and it works similarly, but we're now talking about this with charges. So there's two different types of charges that we talk about oftentimes, and they are positive charges, which will make blue for this example, and negative charges, which will make red for this example. And I didn't mean to make it so much bigger, but that's fine. So let's just deal with it. Okay. Okay, cool. So we know, or we decided back in the day that, okay, these two things are different. They act differently. We know that positive and negative are attracted towards each other. And we know that if you have two like charges, those two like charges are going to repel, right? So positive and negative, they want to come together, but positive and positive, they want to push apart. And so let's kind of look at what that means, right? So a positive charge is generally said to have a field that pushes outward all directions around it. So remember, this isn't just in the two-dimensional plane that I'm showing you, but rather in all three dimensions all around the outside. And similarly, negative charges actually pull things in all around the outside. And this is, again, an arbitrary determination. It's a choice that somebody made back in the day that we just stick with. All right. That's just kind of how it works. It's the convention, if you will. Okay. So let's take a look at these field lines, right? So if we carry these lines out, right, they're going to like do this, right, out in all directions, around the outside of the red one, the negative charge. They're going to do this, right? And then let's look at the blue one, shall we? So the blue one's going to have field lines that go out like this, go out, hello, there we go, go out like this, go out like this, right? And you're going to see these lines are going to, ooh, hello, these lines are going to start interacting. Okay. And so where these interactions happen is actually kind of, you can sort of see what I've done now. You can kind of trace it even. Where these things would be interacting, you actually see the behavior of objects that are in this space is that they actually travel along arcs, right? So what's interesting about the straight line here is that if it's going straight from here, from positive to negative, it basically takes it. That should be a straight line. I'm really sorry. It should take a straight path from here to here, straight through, right? Now, an object that's in this area is actually going to take a curved path like this. This is going to take a curved path like this. You can then trace the field out to kind of look like this. So we're now looking at the interaction between these fields, right? And it even gets to be as drastic as the lines that are going straight out like this over time. They may end up even curving. Oops, sorry. Even I hit my tools down there at the bottom, even curving together, right? So these ones might end up curving together as well. And that's about as drastic as it gets, right? Anything on the other side, they're going to not really feel the effects too much. There might be a little bit of curvature like this overall. It, depending on how close the particles are. If the particles get really close together, then these lines are even going to start trying to connect, right? They're going to make these curving paths, right? So that's kind of what it looks like. And anything that's in this field of influence is kind of going to feel that pulling, and there's going to feel that strength of that field. And you can see here that my lines, they never cross each other, right? So like this line here is never going to cross another field line. This line here is never going to cross another field line. That's the idea, right? And generally speaking, the more lines you have in this area, the more like the stronger the field is supposed to be or is indicated as, right? So when you're actually measuring this in reality, and you're trying to recreate where these lines or these field influences might be, the lines are the strong places and the weak places are the space in between, which is a little bit different from gravity because gravity is affecting everything all the time, everywhere, right? So these fields actually have areas of strength and weakness. And in this diagram is kind of like dependent on the space between them, right? So like the field is much weaker in this area out here relative to in this area in here, right? Because there's not very much space between the lines. At least that's kind of how it's supposed to look, right? So that's how that looks, right? So what if we go and we look at an example of one where they are the same charge? So we're talking here about same charges in electrical fields, okay? So we've got two positive charges and they're meant to be the same size. I'm sorry, I just am not terribly good at the drawing. So remember, positive charges are sending out fields in all directions, right? They're sending out their field lines in all directions, and they're bigger the nearer they are to them, right? The influence of the field is bigger the nearer they are to them. Okay, so we've got this situation here, right? And if you've got this situation here, you're going to start saying like, okay, well, what about these lines, right? They're eventually gonna cross each other, and even right here, right? So that's pretty wild. What happens? It's a great question. what happens is these lines, since they are from the same charge, right? They can't actually be, they can't be together. They don't like being together. So what we have to do is figure out, well, what is that actually going to do? What's going to happen to an object that's in that area? What's going to happen there, right? So what ends up happening is similar to when you bring two magnets together that are the same side, like north and south, right? They're going to start pushing apart. So the closer you bring these two particles, the less they're going to want to be together. And how you can actually visualize that is that their field lines are going to start pushing away. So let me just really quickly take some of this stuff out of our way here so that we don't have to worry about it too much. Okay. Let me get some of this stuff out of here. Okay. And we're going to start talking about what these lines are going to do. So we'll especially start talking about the nearer field lines, and we're going to kind of ignore the ones on the outside for now, just because they don't change too terribly much. Okay, that's probably good enough for now. All right, cool. So if we've got a line from this line or from this charge, as the field influence is getting closer, it's going to start getting deflected away. And similarly with that of the other charge, those lines are like, we want to be together, but not that bad, right? Because we have the same charge, we have the same influence, and you're actually going to start seeing your field lines kind of taking these paths where they're like, okay, like I'm leaving my charge at this, going in this direction, but I'm getting deflected. Something's causing me to deflect, right? So that's kind of how you're going to see with positive charges, right? So positive charges, the field line looks kind of like this. Now negative ones, it looks almost exactly the same, but with two negative charges, it's a little bit different because the lines are supposed to be going toward, right? So you're going to actually see a similar drawing, but now the arrowheads are pointing, and I'm having a hard time with my hands today. You're going to see these lines kind of doing this, right? As they kind of come in. And I'm only showing you what happens on the 1/2 because what's happening over here is more or less, wow, that line, more or less the same thing as before. Okay. Same thing with the positive charges. So I just wanted to make sure that that was very clear to you, so you kind of see how these interactions work. We're going to be kind of visualizing this a lot more in the lab, and hopefully you'll be able to answer some questions about what actually happens to objects that are in the influence of these fields. Like how strong is it? How weak is it? What's going on in these particular places? So we're going to be putting charges in positions like this and then seeing kind of what they do to each other or to things that are in those field spaces, because that's what's actually interesting. You can visualize this all you want, and you can say, oh, hey, like all of this makes sense, but what actually happens when you put things in the influence of these fields? That's what we're going to be doing next.